Hello guys, welcome to this video. My name is Juan, and today our focus will be practicing working with complex numbers. We will solely focus on learning how to add, subtract, multiply, and divide complex numbers. Let's get started with our first question. Our first question is expressing it as a plus bi. We're adding 2 plus 3i with 4 plus I. Here we'll treat these two numbers the same as we'll treat numbers with variables. We want to only add like terms. So here we see that the 2 and the 4 are like terms, while the 3 and the I are like terms, so we'll just simply add those two together. And this is how we'll generally tackle addition and subtraction. So we have 2 plus 4 and 3i plus I. And we'll see that 2 plus 4 is 6 and 3i plus I is 4i, giving us an answer of 6 plus 4i. This is the same thing as subtracting. We just have to be careful with negatives there. So we'll move on to multiplication. This time, for this question, we're going to multiply 2 plus 3i times 4 plus I. And if you recall distribution, FOILing, all we're doing here is making sure we multiply everything on the first parentheses with everything on the second parentheses, like so. We're going to multiply 2 times 4, 2 times I, as well as 3i times 4, and 3i times I. In doing so, we get 2 times 4 is 8, 2 times I is just 2i, 3i times 4 is 12i, and 3i times I is 3i squared. You can think of multiplying numbers with numbers, letters with letters. So when we see 2 times 4, 2 times I, we have 2 and I just sticking together. Or we see 3i times I, we just have the i's together. You will notice we do again have like terms here. We have 2i and 12i. We could join those together. And we will also notice that we have I squared. I squared, by definition, should be just -1. So we'll make that change right away. And we have 8 plus 14i minus 3. -1 times 3 turns out to be -3. And now again we have one more pair of like terms, the 8 and the -3. So we're going to do that last simplification, and we come up with our answer of 5 plus 14i. The next problem, we're going to try and divide two complex numbers. We have 2 plus 3i divided by 4 plus I. Here, we want to simplify the denominator, and we're going to use the complex conjugate. The complex conjugate of the denominator is just the same expression, except with a minus sign instead of a plus sign with regards to the imaginary component of the expression. So 4 plus I, its complex conjugate should be 4 minus I. Multiplying top and bottom by 4 minus I lets us keep our equation just about the same, since we are multiplying by just 1. Anytime we multiply by 1, we haven't really done anything to our expression. We do have to multiply both top and bottom, and this just turns out to be the same as our previous question, where we're multiplying two complex numbers. And like before, we're going to FOIL those out. So we're going to have to multiply everything from the top, parentheses, with 4 minus I, and the same thing with the bottommost parentheses. So it's, as you can see here, it's all there. And let's go ahead and do that. 2 times 4 is 8. 2 times negative I is negative 2I. 3I times 4 is 12I. 3I times negative I is negative 3I. 4 times 4 is 16. 4 times negative I is negative 4I. I times 4 is 4I. And I times negative I is I squared. Just like before, again, we're going to combine those like terms. We have a pair on the top and a pair on the bottom. We have negative 2I plus 12I, and we have negative 4I plus 4I on the bottom. You will see that at the bottom, if we did this correctly, should always have the like terms cancel out, at least in terms of any terms that have I in it. So, and don't forget, we could make I squared into negative 1 as well. So, doing so, on the top, negative 2I plus 12I would be 10I, and conveniently, the bottom, negative 4I and plus 4I should cancel out. On top, we again substituted that I squared, and now we have plus 3, and on the bottom, we have plus 1. So, one more round of combining like terms and simplifying this expression, we should get 8 plus 3 and 16 plus 1. Adding 8 plus 3, we get 11. So on top, we have 11 plus 10I, and in the bottom, we have 17, 16 plus 1. Now, we do have to separate this fraction into two separate fractions to express this as a real term with a imaginary term. So we're splitting up the real and imaginary parts here. So our answer ends up being 11 over 17 plus 10I over 17. And that's it. This was just a pretty easy start with adding, multiplying, and dividing complex numbers. And if you enjoyed this video, go ahead and hit the thumbs up button and subscribe. Thank you very much.